Now we're going to move into session 3. We'll talk about EPA's oversight of emerging technology pesticides. I'd like to introduce Alan Reynolds, who'll be talking about the history of pesticide biotechnology at EPA. Alan has been with the Biopesticides and Pollution Prevention Division for over 20 years. He currently acts as our biotechnology team leader and product manager. Alan came to EPA after working with Fred Gould at North Carolina State, and he's an entomologist and IRM expert in addition to being the product manager for biotechnology. So with that, I'd like to introduce Alan.
Thank you very much, Mike. Good morning, everyone. And as Mike mentioned, we have a little difference in the title of my talk here. I'll be providing an overview of how the Emerging Technology Branch regulates pesticidal products of biotechnology. But as part of that, I will be going through the history of how we've done this over the past few decades. First, just an outline of the presentation. The first two topics, an overview of the different types of biotech pesticides that we've seen and the laws and regulations that govern how we regulate these products. Two of my colleagues this morning went through those with preliminary talks, so I'll just be providing a fairly limited recap of those. And then I'm going to specifically talk more about the regulatory products that we work with for biotech, in particular experimental use permits and biotech notifications that allow for testing of new technologies, and then registrations which allow for the commercial use of biotech products. And then finally, I'm going to get into some of the core principles that guide our regulatory program, including the use of sound science, particularly how we involve the FIFRA Scientific Advisory Panel as part of that process. And then I'll be talking about how we build public trust through transparency and soliciting opportunities for public involvement in the regulatory process. I'd like to just start off by first going through EPA's 5 principles that influence and govern how we regulate biotech. And these 5 principles are really applicable to all pesticide regulation, not just biotech. But I think they do have added importance as we start to look at novel traits, particularly novel biotech approaches to pest control. So these principles are the use of sound science, ensuring transparency as part of the regulatory and decision-making process, ensuring that we maintain consistency and fairness throughout our regulatory oversight. Also collaborating with our various regulatory partners, both the federal and state levels, and then finally building that public trust with our regulatory oversight and the regulatory decisions that we make. I just want to briefly go through the various types of biotech pesticides that we've regulated. My colleague, Biopesticides provided a very nice overview, so I'll try to do this relatively quickly. By and large, the biggest category is in the plant-incorporated protectants, or PIPs. Biopesticides provided a very nice definition of those. They're essentially it's pesticidal substance that's produced as well as the genetic material that's necessary for its production. We're really talking about DNA, RNA, and the proteins that are produced by those introduced traits. A typical example would be the Bacillus thuringiensis cry1a B protein and the gene that would be inserted to produce it. But also as part of this PIP definition, we consider inerts. And in the context of PIPs, an inert would be a selectable marker gene, something like the CP4 EPSPS trait, which confers resistance to glyphosate. So when those traits are used as markers for the PIP, those are considered to be inert ingredients, and we do have regulatory authority over those. In addition to PIPs, we've also regulated genetically engineered microbes, and these can include things that are produced by those microbes, either proteins or peptides that the microbe has been engineered to specifically produce. RNA interference, and we've heard a little bit about that this morning. So far, we registered an RNAi trait as a PIP. We have not yet seen any applications for exogenous or sprayable applications of RNAi, but we're expecting to see some of those things come down the pipeline probably in the next few years. Finally, we also briefly heard this morning about GE organisms. In particular, in this case, we're really just looking so far at the mosquitoes that have been engineered to be self-limiting. Okay, so I want to talk a little bit about PIPs, since this is the biggest group of biotech pesticides that we've had the most experience with. PIPs have been around for a while. The first PIP registrations were issued at the mid-1990s, and they were done in corn and cotton varieties. So that means EPA's had several decades of experience regulating these products. Right now, we've had more than 100 PIP products that are registered. Actually, I think that number is closer to 150 now. The vast majority of these are based on Bacillus thuringiensis cry proteins that are targeted specifically for insect control. And these traits have been engineered so far mainly into corn, cotton, and soybean. More recently, though, we have seen the first RNAi trait that was engineered as a PIP, and this was the DB-SNP7 trait, as my colleague Biopesticides went through this morning. And this has been engineered specifically for corn rootworm control. And this is notable because it's the first RNAi that has been approved for control of a macroorganism, in this case, an insect. We've also seen some other PIPs targeting plant diseases. Some of these are based on viral coat proteins. In particular, we have registrations for varieties of papaya and plum. We also have an active experimental use permit for a spinach defensin protein that is targeting citrus greening, a big problem, of course, in Florida. And we've also recently registered a VNT1 trait. It's a resistance protein in potato that confers resistance to late blight. To date, we've largely seen, except for those plant disease examples, most of the BTs have been registered in large row crops by big companies, multinational corporations, but we are expecting to see a change in the future. We are expecting to see a greater diversity of products and different types of cropping systems, as well as the involvement of small companies and researchers also getting into the biotech arena. My colleague, Chris Wozniak, will go through some of that horizon scanning in his presentation a little later. So I just want to briefly go through laws and regulations that govern how we regulate biotech, and I think really the take-home message here is these are the same laws and regulations that govern all pesticide regulations, so we're really not different in that sense. So we're operating under the big acts of FIFRA and FFDCA, also the Food Quality Protection Act, and as my colleague Kara Welch went through, PREA, the Pesticide Registration Improvement Act. The laws, that's what passed by Congress. The regulations are how we implement those laws, or our playbook, if you will. For us in the pesticide program, our rules are codified in the Code of Federal Regulations under Title 40. The pesticidal portion of that is Parts 150 to 189. There is a specific chapter, Part 174, that deals with PIPs. My colleague Elizabeth Milewski did a very nice job of describing that regulation and a little bit of the history associated with it. Just real quick on FIFRA and FFDCA, as Kara explained this morning, FIFRA is the law that governs the distribution, use, and sale of pesticides. This is done through product registrations that are authorized under Section 3 of the Act. There are also other types of registrations that you may be familiar with, including emergency exemptions and special local needs. We do see some of those occasionally for biotech, particularly with the PIPs. FIFRA also mandates that EPA conduct a periodic reevaluation of older pesticides, and under Section 4, this is the re-registration or registration review processes. They're also applicable, of course, to all our biotech pesticides as well. FIFRA also allows for field testing of novel traits or pesticides under Section 5, and these are done under experimental use permits, or in the case of genetically engineered microbes, biotech notifications. On the FFDCA side, this is the act that mandates that EPA establish a tolerance or tolerance exemption for each pesticide that could be in food. These tolerances, of course, apply to PIPs. The take-home message here is that all the PIPs that we've registered to date, actually, in fact, all of the active ingredients we've registered so far in the Emerging Technologies branch have had tolerance exemptions. And that's a reflection of their relatively low risks in terms of food safety. I just want to also go through some of the important regulations that are in 40 CFR that pertain to biotech. Dr. Milewski this morning went through Part 174 pretty thoroughly, but I'll highlight some of the important regulations that are there that we frequently work with. 40 CFR Part 174.25 establishes a exemption from the requirements of FIFRA registration for PIPs that are created from sexually compatible plants that come about through conventional breeding. So that's an exemption that was put in specifically in place to cover these cases where a trait may be conventionally bred from a sexually compatible relative. A similar exemption is on the books, 174.705, that would cover inert ingredients that are created through that similar sexual compatible conventional breeding process. Under Part 174.500, the PIP tolerance exemptions are created and listed out there. One of those exemptions in particular is noteworthy. Under 174.507, there's a tolerance exemption on the books for nucleic acids that are part of a PIP. And this was important because this is a tolerance exemption that was used for the first RNAi PIP that we registered, the DB-SNP7 trait, because that is a trait that is made of nucleic acids. It fit within that existing tolerance exemption. Also under CFR Part 172, that's the section that covers EUPs and biotech notifications. I'll be talking more about EUPs and biotech notifications in a couple slides, but EUPs are essentially required for testing on more than 10 acres for each pest. Biotech notification is required for small-scale testing that would be on less than 10 acres for genetically modified pesticides. Also in CFR Part 158 are the data requirements for various types of pesticides. Under Part 158-2000 are the biochemical pesticide data requirements. These data requirements would have applicability to some of our biotech products. They could be applied to exogenous or sprayable formulations of RNAi. They also have been applied to proteins that have been produced from genetically engineered microbes when the microbe is not actually part of the final product formulation. So in that case, we treat those more as biochemicals. Part 158-2100 covers microbial pesticides, so they're applicable to our genetically engineered microbes as well. And it's notable these microbial data requirements were used to inform our PIP data requirements, since many of our PIPs have been derived from a microbe, Bacillus thuringiensis. I just want to quickly talk a little bit about the developmental process and sort of how EPA fits in there. Generally, novel traits, biotech products follow a stepwise progression through the regulatory process. So starting early on, I will typically consult with developers during that research and development stage early in the process, often a long time before they're actually ready to come in with a submission. But the earlier we can consult with a developer, we can be more involved with shaping the data needs that would be needed to support various EUPs or registrations through that regulatory process. So early involvement, I think, is a really key component to smooth regulatory oversight. Step 2 typically involves field testing through an experimental use permit. At this stage, we would likely be issuing a temporary tolerance exemption that would be coordinated or synchronized with that EUP if there's any possibility of food residue. Step 3 typically involves a limited registration. In the case of PIPs, that's often a seed increase, what we call seed increase registration. I'll talk a little bit more about that in a few slides. At this stage, though, we generally would have a permanent tolerance exemption in place, since this would involve larger field use. And then step 4 is the final commercialization, where you would have essentially a full, largely unlimited registration, as well as that permanent tolerance exemption in place. Okay, so I want to talk specifically about experimental use permits for biotech pesticides. First, the purpose of the EUP, it's designed to enable a developer to do field testing to generate data to support registration. And that's a really key point. It's not just a generic approval to do any testing. The testing really needs to be able to support the data that would be needed for a full registration. So the trigger for an EUP is that any testing on more than 10 acres of land, and then that's per pest, or more than 1 acre of water, if it's an aquatic use, would require an experimental use permit. And as I mentioned earlier, if there's any possibility that there would be exposure to food or food residues, we would need to have a tolerance or tolerance exemption in place. At the EUP stage, these are typically temporary exemptions that are synchronized with the duration of the EUP. We generally don't see a full data set when we're looking at an EUP. It's typically a subset of the data that we would look at for a full registration, with the caveat being that we really do need to be able to establish that temporary tolerance exemption. So we'll need to have a pretty good feel and understanding of certainly food safety, and we would need data to support that. And as part of the EUP process, we'd be looking at both active and inert ingredients as part of the review process. I got a question earlier about containment. It is a very important part of our EUP oversight. We have issued some EUPs for what we call non-food uses. This would be an EUP where there would not be a temporary tolerance exemption. So in those cases, it's absolutely critical that we have a containment program that will ensure that that trait cannot get out and into the food supply where we don't have a tolerance exemption established. Looking at PIPs, when we're focusing on containment, we're often looking at movement of pollen and outcrossing of pollen and trying to prevent that as best as can be done. For example, looking at corn, we would look at different isolation techniques, such as spatial isolation, reproductive isolation, which would involve actually physically bagging or detasseling corn, or in some cases, temporal isolation. Planting times would be staggered so that you would not have synchronous pollination. And as I mentioned, if we do not have that tolerance exemption, we must ensure that anything that comes out of that EUP, any harvestable produce, absolutely cannot enter the food supply. So there would be a crop destruct provision in place in those cases. We do on our website have some good guidance for small-scale field testing, as well as low-level presence of PIPs in food. Similar to EUPs, I'd like to just briefly discuss biotech notifications. This is sort of a unique case. It kicks in for genetically engineered microbes on small-scale testing, so this would be less than 10 acres. If the testing is going to be on more than 10 acres, we would be requiring EUP in those scenarios. This covers those very small tests. For these biotech notifications, EPA will review those on an expedited manner. We typically finish our review within 90 days. Part of that review will make a determination whether we would need an EUP, even at that less than 10-acre level. There could be some scenarios in which we might require an EUP at less than 10 acres if there are risks that would warrant us needing to do a fuller review and possibly having a tolerance exemption in place. Typical information that we would be looking at this biotech notification stage would include a characterization of the microbe. We would need to describe the modifications that were made, how it was engineered, what traits are expressed. We'd be looking specifically at the proposed experimental protocols, where they are, how much acreage is involved, the testing program, and then also very importantly, we would be looking at containment procedures, similar to what we would do with EUPs. At the biotech notification scale, containment is probably even more important because we don't often have a temporary tolerance exception in place at that point. So we really need to make sure that the testing is in fact contained and will not result in any residues getting in food. There are a couple scenarios where we can exempt genetically engineered microbes from that requirement for biotech notification, and these are described in Part 172 of 40 CFR. One scenario is if there's a single genome deletion or rearrangement that comes about from an introduced genetic material. In those cases, just a single genome deletion or rearrangement, that can be exempted. Testing can also be exempted if the microbe has been inactivated or made non-viable through, like, say, a heat kill step or something like that, so that it's not viable in the environment, and that can be documented with data. In those cases, we can exempt those types of products from going through that notification process. Okay, well, I'll talk a little bit about biotech registrations. The different types we look at. I mentioned briefly before about seed increase registration for PIPs. This is kind of an intermediate step between the EUP and the full commercialization. And really the goal of the seed increase is to allow the registrant to be able to bulk up their inventory to produce enough seed so that they can have a commercial launch for widespread distribution to farmers. Now, there's a specific category of seed increase registrations called breeding line intermediates that we also have some experience with. And a breeding line intermediate would be used when the registrant has a commercial product that contains multiple traits. And this is actually very typical now. Most of the PIPs that are registered, in fact, are combinations of different BT traits. So the final product illustrated on the graph here on the right, in this case, would have 5 different traits in it. And they originate from 5, on the far left here, different single trait products that are then combined using a conventional breeding process to make that final 5-trait product. So to do that by conventional breeding, you have these series of intermediate steps in the middle here. So you start and the first step is you have these 2-trait combinations, and they're bred to make 3-trait combinations, and so on and so forth. But it's these intermediate steps that need to be also registered under FIFRA. And so to do that, we issue these breeding line intermediate registrations. And they essentially function as seed increase registrations. They're not intended for commercial use, but they do allow the producers to plant significant acres of the crops to do this conventional breeding. On these seed increase registrations and breeding line intermediate registrations, we typically have an acreage cap. And that's done for resistance management purposes to limit the overall use of the traits so that we don't have an excessive amount of selection pressure that could quickly lead to resistance. And as I mentioned earlier, even though these crops are not yet in a commercial state, we still would need to have a tolerance or tolerance exemption in place for those. Now looking at the commercial use registration, so this would be essentially what the farmer would buy as far as seed and actually plant and use on a widespread basis. These registrations typically would not have the limitations of a seed increase registration as far as an acreage cap or something like that. However, most of the PIP registrations that we've issued to date do have expirations, so they are time limited in that sense. And the reason we do that is to give us a chance to go back and periodically reassess those various products, see if there are any new data or anything we should be doing differently, for instance, as part of our IRM approach. But having that expiration date and that time-limited registration provides us a vehicle to do that. So as with any pesticide registration, product labeling would ensure or would establish any precautionary measures that might be needed. We don't have a whole lot of those types of issues with the products we've seen to date. By and large, the issue that we need to mitigate most is resistance and our insect resistance management strategies. So those are typically required for commercial use BT PIPs. My colleague Eric Bonenbust will be going through a little bit more about resistance management and what's done there. And of course, with commercial use registration, we would need to have that tolerance or tolerance exemption in place. Okay, I want to segue into how we use some of our 5 principles as far as our regulatory process. And one of the most important ones is the use of sound science. Our standard is that EPA's risk assessments are based on best available science. They're based on scientifically rigorous data. They go on extensive public comment and peer review within the agency and outside the agency. And this standard is not just true for biotech, it's really true for all pesticide assessments that are done here in the Office of Pesticide Programs. But certainly with biotech, we take that standard very seriously. To illustrate how we've applied sound science, I'd recommend taking a look at the URL provided on the slide that links to the Plant Incorporated Protectants Data Symposium we did a few years ago, which describes specifically the types of data that science that we've used in our evaluation with PIPs and how that fits into the regulatory process. So that's, of course, in much more detail than we'll provide this morning, but I'd highly recommend if anyone's interested in how we regulated PIPs, take a look at that. It's very comprehensive. A huge part of how we endeavor to incorporate sound science is our use of the FIFRA Scientific Advisory Panel. Now, the SAP, it's an expert body of independent scientists and experts who provide EPA with peer review and guidance on various scientific issues related to pesticide regulation. So the SAP has been absolutely critical in establishing our regulatory paradigm for PIPs. I counted at least 24 meetings, I think I may have even missed a few, that we've had related to biotech and PIPs over the years. The types of topics that we would present to an SAP or take to an SAP include human health issues, effects to non-targets, other environmental risk assessment concerns, gene flow, and insect resistance management. So these meetings are public. They're conducted under FACA, so they're open to anybody. The reports are made available on the SAP's website. And for more information, I'd recommend folks take a look at the SAP's website. This next slide, which probably no one will be able to read, I actually created a table of all the SAPs related to PIPs that I could find. As you can see, they barely fit on the slide here. But our first meeting was all the way back in 1992. Our most recent meeting was just a few months ago in July. So it's useful to illustrate how frequently we've used the SAP over the roughly 2.5 decades we've been regulating PIPs and how important it is to us and our continuing use of it even after we've approved the first generation of PIPs. The last topic here, I want to talk about how we try to build public trust. And we do that by endeavoring to be transparent and make available as much information as we can. So all of our risk assessments, benefit assessments, regulatory decisions, all of this information we'll publish on our website or in dockets as appropriate. Also SAP meeting reports and other relevant materials that are of interest. We'll endeavor to make those available on our website. I put the link for BPPD's website on the slide here. It's a very useful source of information on biopesticides. Also on the regulatory process, there's some good guidance for registrants. And there's a very nice overview of how we regulate PIPs and some more specific information on each individual PIP that we've registered so far. As far as opportunities for the public to be part of the regulatory process, there are a number of opportunities for public comment. The traditional means that we've done this has been through the use of the Federal Register, which creates comment periods, typically 30 days. So when we receive a new application for an active ingredient, so if we've got a new biotech product in, I've never seen it before, new active ingredient, we would publish a notice of receipt in the Federal Register, which essentially announces that we've got the application. That then opens up a 30-day comment period. Similarly, for a proposed tolerance exemption, when we get a petition for an exemption, we'll publish a notice of filing in the Federal Register. That also opens up a 30-day comment period. And then any rulemaking process, that will also trigger comment periods as well. So in addition to those sort of basic FR comment periods, there's also the OPP public participation process. I think a number of folks in here probably already know about that. But this was established, I think it was in 2009, as a way to involve the public in a proposed decision. So instead of, as we announced in the Federal Register that we've just received an application, the public participation process allows the public to look at what we're proposing to do about it. So what is our proposed regulatory decision? And then opens up a comment period. For the actions that BPPD looks at, our comment periods are typically 15 days under this process. And we would open public participation for significant new actions. So those would be regulatory decisions on new active ingredients, first food uses, first outdoor residential uses, or any other significant action that would be of interest. And then details of this process are described on the website link on the slide here. There also have been many public meetings related to biotech, and there I'm sure will be many more. SAPs are, of course, a big part of our process. Also, the PPDC, as well as other specific workshops that we hold on a periodic basis, are a good way for the public to be involved in what we do. Okay, and I'll just close with one final slide that just provides general information resources on our website that pertain to biotech. So I'd recommend folks, if you're interested, check some of these out. There's a lot of good information there.